Indices. Indices is the index or power or exponent of a number. That is how many times a number is used in multiplication. Example, we have 5 times 5 times 5, which is 5 in 3 places. So in indices form, we represent as 5 raised to power 3. That means 3 is the index of 5. Another example, we have 4 times 4, which is 4 raised to power 2, where 2 is the index of 4. Okay, for index decimal, that's for index with decimal, we have 4.5 all raised to power 3, which is expressed as 4.5 times 4.5 times 4.5. Find the value of 0.2 all raised to power 4 and 2 over 5 all raised to power 5. For the first one, 0.2 all raised to power 4 implies 0.2 in 4 places, which is expressed as 0.2 times 0.2 times 0.2 times 0.2, which is 0.016. And for 2 over 5 all raised to power 5, that's 2 over 5 in 5 places, which the answer is 32 over 3,125. Addition and subtraction of index numbers with different bases. We have 3 raised to power 3 plus 4 raised to power 2, and we have 6 raised to power 3 minus 2 all raised to power 4. Now for number 1, we can see that we have different bases, that's 3 and 4. The same thing for number 2, we have 6 and 2 as different bases. So for the solution now, 3 all raised to power 3 plus 4 raised to power 2 can be expressed as 3 times 3 times 3 plus 4 times 4, which 3 times 3 times 3 is 27, and 4 times 4 is 16, where we have it as 43. For the second one, 6 raised to power 3 minus 2 raised to power 4 is the same thing as 6 times 6 times 6 minus 2 times 2 times 2, which is 200. For multiplication and division of index numbers with different bases, which is 3 raised to power 3 times 5 raised to power 2 times 2 raised to power 2, we have it as 3 times 3 times 3 times 5 times 5 times 2 times 2, which amounts to 2,700. Then for the second question, which is 3 raised to power 2 divided by 4 raised to power 2, that's 3 in 2 places divided by 4 in 2 places, which gives us 9 divided by 16, which we have as 9 over 16. Moving to law of indices. Laws of indices. Now in this place, we'll be looking at some few rules we need to know to answer any question in indices, which we have number 1 as a raised to power m times a raised to power n. In this case, notice that the bases are the same and the powers are different. So when the bases are the same and it is in multiplication form, you add the powers. For the second one, the same base, different powers, so subtract the powers. For number 3, whenever you have any constant raised to power 0 or any value raised to power 0, it always gives us 1. For number 4, when we have an expression like a raised to power m all raised to power n is the same thing as a raised to power m times n. You just multiply the powers, and so on. Simplify the following. 3 all raised to power 3 times 3 all raised to power 4 is the same as 3 raised to power 3 plus 4. Just note, when you have a multiplication in between the bases and its powers, you would add the powers together, so which gives us 3 raised to power 7. Number 2, x raised to power 4 times x raised to power 3 is x raised to power 4 plus 3, which is x raised to power 7. For number 3 now, we are given 5y raised to power 3 times 2y raised to power 2 times y. In this case, you multiply the coefficients of y, that's the values beside y, you multiply them together, then you also multiply y or the y together, which is 5 times 2 times 1 times y raised to power 3 times y raised to power 2 times y raised to power 1, where 5 times 2 times 1 is 10. And in this case, in the case of y, you add the powers because of multiplication. That's y raised to power 3 plus 2 plus 1. Finally, we have it as 10y raised to power 6. 4 raised to power 5 divided by 4 raised to power 3 is the same thing as 4 raised to power 5 minus 3, which is 4 raised to power 2. In this case, you just subtract because of the division sign. For x raised to power 7 divided by x raised to power 3, the same thing, x raised to power 4. And for 8y raised to power 6 divided by 2y, in this case, you express it in fraction form, which is 8y raised to power 6 over 2y. Okay, so that becomes 8 times y in 6 places over 2 times y. Therefore, 2 in 8 is 4, then 1y cancels 1y, which we are now left with 4y raised to power 5. Okay, number 7, we have 4 raised to power 0. In this case, it is automatically 1, because from our law of indices, anything raised to power 0 is 1. And for number 8, 3a raised to power 0. It can also be expressed as 3 times a raised to power 0, which a raised to power 0 is 1. Therefore, 3 times 1 is 3. 4 raised to power 2 raised to power 3. From our law of indices, you just multiply the powers, which is 4096. And for number 10, 3a raised to power 2 or raised to power 2 is the same thing as 3a raised to power 2 in 2 places, which is 3a raised to power 2 times 3a raised to power 2, which we have as 9a raised to power 4. And finally, 27 or raised to power 1 over 3 can be expressed as cube root of 27 or raised to power 1, where the cube there is the 3 that represents the denominator and the 1 is the numerator. Finally, we have our answer as 3. And for number 12, 4 raised to power minus 3. From one of our laws of indices, whenever we have something like this, it's the same thing as 1 over 4 raised to power 3. Okay, where the minus is as though representing 1 over 4 raised to power 3.